So I was at the bar the other night, right?
Oh yeah? What bar?
No, that doesn't matter. So I was at a bar the other night, right? And so I was sitting down at the bar, and the bartender, he comes up and gives me a drink. I don't remember the drink.
Probably gin and tonic, knowing you.
Well, okay, yeah, maybe. Anyway, so I was sitting there, and then this really hot girl comes and sits nearby, and we make eye contact, and she's brought over a drink, and we're just looking at one another, Our eyes are locked, and I could really tell that her eyes were saying something beautiful and meaningful, and they were just saying to me, please stop looking at me.
That's harsh. She turned you down without even saying anything.
On the contrary, I think the eyes usually say a lot more than actual words sometimes. It's usually the first form of communication between two strangers, and it's often very effective. It's also the topic for our podcast today. Eyes, the windows to our lives. It says lies here, but it should be lives.
Oh yeah, I changed that because it seemed to rhyme better.
Well, it does, but we're not the poetry podcast. We don't need to rhyme.
Well, that is true. Well, anyway, good morning and welcome to the Casual Science Podcast, where we bring to you scientific concepts over 3 cups of coffee. Just an interesting but light way to start your day. I'm Randall.
I'm Hubert, and today we have with us a special guest, Ben.
Hola, I am Ben.
Eyes have always been a huge part of language. As a matter of fact, there are tons of sayings that reference or just contain the eyes.
Oh yeah, like the apple of my eye. Fear is in the eye of the beholder. An eye for an eye. I is the 9th letter of the alphabet, and I have run out of facts.
And so on and so forth. Today, however, we aren't going to talk about language as it is English or Chinese or French. We're instead going to talk about language as communication between people, or just living things in general.
That's absolutely right, Hubert. So before we get into the nitty, itty, gritty, bitty of things, let's get one thing straight. Are people actually influenced by the gaze and eye language of the people around them?
I recently read an interesting article about this, actually. You can test this out for yourself when you're out eating with friends.
What if you don't have friends to eat with?
Oh, that's easy. First, you have to infiltrate another group of friends eating.
Yeah, that's really easy. Step 1, buy a Mac.
Step 2, find a Starbucks. Step 3, find some social political issue you don't really care for and start complaining about it really loudly and wait for someone to chime into your problem so you can join them and get yourself a new group of friends.
Common topics include gluten, Trump, and the declining brick and mortar industry for books.
Good advice and all, but if we're at Starbucks, we won't be eating anything.
Oh, touché. So, in the study I mentioned before, we actually use our gaze to basically tell others not to look at us while we eat. So in the experiment, it was first shown that it was normal or rude to look at others when they began to eat, and that we ourselves take a look down at our food before we begin to eat it. That looking down is a signal for intention to eat.
Ah, I get it. So basically, when you look down and signal to me that you're going to take a bite, I'd have the normal reaction of looking away since it's rude to look at you while you eat as a social norm.
Exactly. This is a perfect example of our eyes communicating our intentions.
Indeed. And actually there have been many experiments using primates and dogs that have also used the direction of their gaze as a measure of their attention. A common experiment was to have a human looking at the ceiling with their eyes only, then their head only with their eyes closed, then with both their head and eyes, and lastly with neither. Now, both the great apes and human infants involved in this experiment would follow the gaze direction.
Hold on for a minute. I can understand that we use our eyes for communication and all that. That if you're going to look at an apple in a room and I've seen you looking at that apple, I'm going to look at that same apple, but I'm more interested in why, actually.
This is an interesting topic. If you think about humans as another species of animal, we're actually very strange.
Well, to be fair though, I think just in general humans are really strange.
Well, let's focus on the fact that we interact with strangers quite a bit. Society as a whole requires humans to cooperate and communicate with one another on a very regular basis, even with strangers who should not be a part of your life. With language, this communication gets easier, but at first glance, simply looking at one another's eyes is a social function that's important to support these frequent cooperative social interactions.
Which then begged the need for our eyes to be discernible from the rest of our faces.
That's a weird thing to say. I mean, our features are quite distinct. Like, I wouldn't mix up someone's nose and someone's eyes anytime soon.
Well, yes, but perhaps it's because our eyes have evolved that way. Okay, take a look in the mirror and take note of the white area around your eyes. That's called the sclera. Now, take note, we'll be using it quite a few times through this podcast. So, the sclera is surrounding a much darker iris and pupil. Now, that's the black or colored part of your eyes. Now, this contrast in colors makes it very easy for us to figure out where we're looking at. Okay, so Google a primate's eyes. Whether it be bonobo, gorilla, or chimpanzee, you can tell that the sclera are much darker in color. And that lack in contrast makes their gaze harder to follow, contributing to a more camouflaged gaze.
And you're saying that humans gave up this camouflage to actually make it easier for us to tell who's looking at what?
To put it simply, yes. This is dubbed by scientists as the cooperative eye hypothesis.
Yep, so it's really easy to follow a human's gaze, and to a certain extent, understand what they're trying to say with a simple glance.
Yes, and that's one of the biggest evolutions our eyes have taken to increase our capacity for language and communication with one another.
I'm gonna sidetrack for a bit here. This coffee, I must say, is exquisite. I'd be tempted to come onto this podcast again, if you told me where you got it.
Now that's a trade secret, my friend, and that's one cup of coffee down.
So, the other day, I was birdwatching, as per usual.
Wait, you birdwatch?
Why, I never! I'm English! Of course I birdwatch! So, I spotted this Asian glossy starling, and I had a strange thought. How do birds see things? Like their eyes are on the sides of their freaking head. How are they eating things that are in front of them? Like, I sometimes have trouble coordinating where I'm eating and my eyes. It's a confusing process eating. It's so odd.
Yeah, tell me about it. You know, I've got these two spotted doves that like to eat rice off my air conditioner condenser thing, and I've always wondered, you know, are they actually looking at me? Like, or are they looking somewhere else? You know, if I go close to them, just walk away, they'll walk away, but I can't tell if they're looking at me or not. It's like sometimes when you talk to people who can't focus their gaze on you, I don't know if they're talking to me or talking to someone else. Do I still pay attention to them? You know what I'm trying to say?
You have pet birds?
Well, sort of.
What did you name them?
Oh, one's Howard and one's Alan.
What kind of normal ass names are those for birds? You just sit around and have tea with them? Good morning, Howard, my dear sir. How are you today? Oh, I'm fine, thank you very much.
Howard sounds like an old-ass dude's name. I'm imagining this bird perched on your air conditioner on a miniature rocking chair, just watching the sunset as you hand-feed it grains of rice. I mean, Jesus, Randall.
But they're good names for birds, though.
For an old man, maybe, damn.
Okay, the point I was getting at. The eyes on the sides of their head is a configuration that's usually found in so-called prey animals. So you've got deer, rabbits, gazelles, antelope, just to name a few. It's quite intuitive actually. They've got eyes on the sides of their head so they can almost see in a 360-degree angle around them, which will be much easier for them to spot any predators coming straight for them.
But if their eyes are in front of their heads, that means they sacrifice quite a bit of visual acuity and depth of perception.
Wait. In English, please.
Alright, so with both eyes staring straight ahead, you can use the information from both of the eyes to better tell how near or far an object is. And your vision is better for focusing on things in front of you, as a wolf would when it's chasing a deer.
And humans, being arguably the most dangerous predators, also have their eyes fixed straight ahead.
Well, I know that's not entirely true, though. Our eyes have a pretty big range of motion, so we can see things to our left and right too, without moving our heads too considerably.
Wow! I'm surprised, Ben. For a moment I thought you were an uneducated bum.
I also do know that if my fist comes into contact with your face at a pretty fast velocity, that it wouldn't change much of your ugly mug.
Ooh, you're right though, Ben. Our eyes have evolved to accommodate a wide range of motion for various reasons. One of those reasons, as we have mentioned before, is the large amount of social interactions that we need to have, in which we use our eyes to seek out people we need to communicate with, and also to pick out visual cues from the environment. People always remember that we look at other people to try and understand what they're feeling by looking at their eyes and their expressions. But we forget that it's a two-way street. People notice that you're looking at them, and that also communicates your intention to them.
Fun fact, the shape of our eyes have a wider horizontal field of view than species of primates that live in trees, simply because we live on the ground, where we're usually looking at things horizontally, and not vertically, unless we lived in trees.
I've always wanted to live in trees.
Why?
Tarzan was my favorite movie when I was young.
And that's our second cup of coffee done. Before we proceed to our final topic, let's have a little recap. Ben, would you do the honors?
I certainly would. Over the years of evolution, our eyes have evolved to help our capacity for language. One poignant way in which it has done so is by making our eyes easily discernible from the rest of our faces. This is clearly seen by how our white sclera... Did I get that?
How white our sclera. But yes, sclera is correct.
Sclera, pardon my French, is compared to the rest of the eye, making it very clear where our gaze is directed towards, instead of it being camouflaged like our primate brethren.
That's right, Ben. And like other predators such as wolves, lions, or bears, we have our eyes at the front of our faces instead of our sides, which helps with, depth perception, focused vision, and basically not looking like a goldfish.
So, I was online the other day, and I found an interesting article that said the size of our eyes actually relates to whether or not we're nocturnal. Is that true?
Actually, yes. To be more accurate, cornea size is actually important to night vision. So the cornea is the transparent front part of the eye, and a larger cornea is linked to more effective vision at night. All primates have large eyes relative to their body sizes, but great apes such as the gorilla or chimpanzees have eyes that are the same size as smaller primates, otherwise known as basal primates or prosimians, such as lemurs or tarsiers. They're basically smaller and much cuter, owing to the fact that their eyes are so large in comparison to their face.
And so the large corneas mean that they have, better night vision?
So basically, for nocturnal animals, they require certain adaptations for increased retinal image brightness. So in order to get increased retinal image brightness, you need to have a shorter focal length, which varies inversely with posterior nodal distance.
I've understood everything so far, obviously, but would you mind repeating it one more for the slower members in our audience? Randall?
Bigger cornea leads to better night vision.
So, does that mean that our cornea size does communicate if we are more active at night than in the day? And if that's the case, if I worked only at night, would my cornea grow larger?
Well, theoretically yes, but perhaps not in your lifetime. It's a slow and gradual process that takes place over millions of years. And while not directly linked to communication, it's another way our eyes have evolved to better suit our modern lives as humans.
And how our eyes have evolved so far indeed. I do actually think that we're running out of time.
And coffee.
So we're going to end off with a fun fact about our eyes. Something really interesting to get you thinking through the day ahead. Hubert?
What? That was all the research I've done already.
Then surely you can just think of something now.
Wow, really putting me on the spot.
I've got this one. This relates to fashion, actually. Our fashion works on the basis of being unique, which explains why we have things that trend and fall out of fashion, like you, Randall, which is simply another way to say that it stopped being unique. Rare eye colors are significantly more frequent in commercial model populations than in the general population of countries, and as a result, those rarer eye colors are favored. Of course, eye color is something you're born with and you can't change it unless you use colored contacts.
And whilst it's not something we've developed over time for language, it certainly is a great conversation starter. Ironic really, because humans in general love to fit in with others, and yet we either condemn or idolize those of us who are unique.
Building on the point that humans want to fit in with others, our eyes are an integral part of that. So when language fails, the direction of our gaze, eye contact, and expressions are all reliable forms of communication that we use on a daily basis. And it's something that has been evolving within our species for hundreds of years.
That's exactly correct, Hubert. And well, seeing as Ben has finished our last cup of coffee, we're out of time today, but I do hope that you've enjoyed our podcast this morning. Once again, thank you to Ben for coming down and helping us out.
Of course, the pleasure is all mine. I mean, the coffee was free, right? I'm Ben.
I'm Hubert.
And I'm Randall, and this has been the Casual Science Podcast. Thanks for tuning in, and see you next week. Then there's the the elevator music. If you like this podcast, please share and subscribe. And smash that like button!